Hi, everyone. So I thought in this video I would look at a couple of the problems that we have in the main course or in the co-requisite course, and just walk us through how to go about solving them. So one of the problems that we had would asked a question along the following lines. Said, and I'll write the question down. So let me get my black pen here. So the question would be something along the lines of um, suppose uh, you want to save for retirement, and let's say we'll give ourselves a number, $100,000 for retirement in, uh, we'll say 10 years. The bank offers an interest rate, a savings rate of, let's say it's a very generous bank, 8.8% um, compounded annually. And you want to save, put aside money every year. So how much do you need to put aside every year? Okay. So this is a typical kind of question. It's on a few of the homeworks that you have this week. And how do you go about solving a question like this? So let's take a look. So the first thing to do is to determine um, what kind of formula you can use to answer this question. And well, this is about retirement, so you can look in the book or look back in the lectures or in the notes and see that in retirement, there's a couple of formulas that are applicable to saving retirement savings. Um, and one of the formulas looks like this. It's the value of your retirement, final value is equal to P times 1 plus R to the Y minus 1 over R. Okay, so this is one of the formulas that you'll see. Um, and then another formula you'll see will look very similar. Would look something like P times 1 plus P to the T minus 1 over P, something like this. And you may be like, well, which one do I use? Do I use the one with the R and the Y, or do I use the one with the P and the T? And the basic idea is if you're going to make this decision, you should um, you should determine what what scenario these formulas apply to. So let me I'm going to slightly modify. So in this formula in the book, they call this M instead of P, and then this lowercase p that I have written is the R over 12. That's what they have. This is what's called the periodic rate. So I was using a more slightly more general formula, but okay. So how do you know when you look in the book and you see two different formulas like this, which one to use for the problem that you're dealing with? Well, you have to ask yourself what these apply to. And this formula applies to saving annually. In other words, putting money in every year. And this one, and this is probably why they use the term M instead of P, refers to monthly, putting away money every month. So look in the problem and say, okay, what is it asking? And it's asking how much we need to put aside every year. So the monthly one is not the one we're after. We're after the formula with the yearly savings. So we can eliminate that and just say, okay, this is the formula that we want to be dealing with. The next thing to do is to say, okay, well, what is it asking? What is the question asking? And okay, it's asking what we want to put aside every year. But what in terms of the variables in front of us is it asking? So in order to answer that question, what you'll need to do is you'll need to identify these variables. So let's write them down. And again, this may require looking at the book a little bit, but each of these variables, each of these letters has a meaning, and we want to determine what the meaning is. So V is the final value of the investment or the retirement. Let's just say fund. P is the annual contribution to the fund. R is the decimal form of the rate. Sorry. Decimal form of the rate. And Y is the number of years of the fund, of the retirement fund. Okay, so we've identified what the variables are in this formula, and that's a very important step here. But it doesn't necessarily give us the answer to the question I was asking a moment ago, which is what do we want? Well, generally speaking, for these types of questions, we want to find one of these variables. We want to find one of these quantities. And in this case, what we would really like and what we don't know is what the annual contribution is. That's what it's asking. How much do we need to put aside every year or annually? So how much do we need to contribute every year to the fund? That's our annual contribution. And also, typically, when you're asked that kind of a question, what you can determine is that each of the other variables you should know. In other words, each of these other quantities should be given to you in the problem. And so you need to play detective for a minute and figure out where they are. So V is the final value of the fund. Can we find that somewhere in our question? So the question asks, suppose that I want to save $100,000 for retirement. In other words, I want the final value to be $100,000. So I'm going to go ahead and say, well, let me move this all over actually, so that I have room. I'm going to say that V is equal to 100,000. I'll leave the dollars off for now. P, I don't know. P, I want to find out. What about R? R is the decimal form of the rate. Well, the bank offers a savings rate of 8%, and you may not see savings rate, it may be APR, but that's annual percentage rate. So it's 8%. 8% is a percentage. So it's not exact, 8 is not R, but the decimal form of 8% is 0.08. So we are given R as well. We are given R. And then Y is the number of years of the retirement fund. And if I look up in here, I said that I'm going to retire in 10 years. So the answer for Y is 10. So great. So we have, out of the four variables, are the four quantities in this formula. We have three of them, and we want to determine the fourth. And so all you do at this stage is you go ahead and rewrite the equation given here. Okay, rewrite this equation, but put in the values that you have. So V was 100,000, so I'll write 100,000. P is unknown, so that is an unknown value. So I'll leave it as P. If it's not known, just leave it as it is. And then I'm multiplying by 1 plus R, that's 1.08, to the Y, which is 10, minus 1, over R, which is 0.08. Great. And at this stage, I want to pull up a calculator. So let's see if I can do this. Okay. And I'm going to go ahead and calculate this part here. I'm going to go ahead and make that calculation. Okay, so how do I do that? I'm going to use some parentheses. I'll put 1.08. I'm going to take that to the 10th power. I'm going to subtract 1. Pardon me. I missed my parentheses there. Here, let's see here. Oops. All right, guys, let's see if I can. Okay, I'm going to subtract 1, and I'm going to just go ahead and get an equality, and then I'm going to divide by 0.08. Okay, and the answer I get is 14.4865. So I'm going to go ahead and write that down. Sorry, 14.4866. Let's round up to the nearest decimal. So I have a P, and then I have times 14.4866. I'll just round up that much. Okay, and now I want to solve this equation where I've got a number times P equals another number. So I'll just divide both sides by that number. So I will go ahead and clear this on my calculator, and I'm going to divide 100,000 by 14.4866, and I get 6,902. So that is what my answer is, equals 6,902. And here at this stage, I will go ahead and put in my $sign, and I'll box off this answer. Now, if you don't want to round, you don't have to make that rounding error at this stage. Back here, you can go ahead and just leave it in that form and divide 100,000 by that number. But this will give you an answer that's very accurate. All right, so that's I don't want students to focus too much on the numbers as much as on the idea of how you go about solving this kind of a problem, which is the strategy is identify what formula you need to use. What is the formula that's relevant to the problem at hand? And then identify what the variables mean in that formula. And then ask yourself, what is the problem really needing? Which of the variables does the problem really ask you to find? And then which of the variables does the problem provide for you? And then go ahead, once you have that information, you can substitute and then solve an equation. Solve an equation. Okay. Let's do one more. Oops, there's some calendars here, but I'm going to forget that. Let's do one more problem. So here's the problem. So here's the question. Oops. Question. All right, so your friend says that he has a great rate of 2% APR on a 15-year loan. On a 15-year loan, which he pays monthly, as I'll say with a monthly payment of only $300. Your friend's private, let's say. I don't know why they're sharing this information with you, but they're so private they don't want to actually tell you the actual amount they borrowed. So the question says, how much did they borrow? So let's look at an answer to this question. And again, the basic outline of how you go about solving this is the same as before. What you want to do is you want to first look and see, okay, well, what formula do I have that really deals with this kind of a problem? Well, this kind of a problem is about an installment loan, and it's asking for the amortization formula, essentially. So in other words, there is a formula that if you know how much you're borrowing, you know the rate, you know that and you know how long the term of the loan, then you can calculate the monthly payment. So all of those ingredients are sort of contained in this question. So we will identify the formula for it, and I'll write it here. So that formula is M equals P, that's the principal. We'll talk about that in a second, the loan, of P times 1 plus P to the teeth power over 1 plus P to the teeth power minus 1. Okay, oops. So let's see if we can identify now we've got a formula in front of us that we think is the relevant formula for this question. Once we know that, we can go ahead and identify what are these variables, how do we use these variables? And again, you'll see, I'm not sure if it's apparent from my handwriting here, this is a capital P, these are all lowercase p's, so there are different variables here, even though they may look a little bit similar here. So in fact, we have 4 variables, and the first thing to do is to try to figure out what is being asked of us. In other words, which variable do they want us to find? Well, let's go ahead and write down what all of these variables mean again. M is, in this formula, the monthly payment, the monthly amount due. Capital P in this formula is the amount borrowed. Lowercase p is this periodic rate. And this is going to equal the APR in decimal form divided by 12. Okay, as before. Capital T is the number of payments, which is typically going to be 12 times the number of years, or if you say the term of the loan. Okay, great. So we've got all of our variables, M, P, and T, all of them are identified. And so let's go ahead and see which of these variables are in the problem. In other words, which of the variables are we given in this problem, and which one are we trying to find? All right, so let's start with M. M is the monthly payment. And my friend says he has a great rate, 15-year loan, and he tells us that his monthly payment is $300. So there we see that actually, yeah, we know this one. M is equal to 300. Right. P, the amount borrowed. Well, hold on a second. So what are we being asked? How much do they borrow? We're being asked how much do they borrow, so we don't know that. So it's an unknown, and it's our job to find out what it is. So this is unknown, and that's what we're going to find out. So hopefully the other two are known. Let's see if we can find out what they are. Lowercase p is the periodic rate. And this one is not given directly to us, but we can find it by knowing the actual rate, the APR. The APR is given to us as 0.2. So we have 0.2, or sorry, not 0.2. It is 2%, which is 0.02. So we have that P is equal to 0.02 divided by 12. Or if you want, it's going to be 1, I guess you would say 2 over 100, so 1 over 600. So I'll leave that in fraction form. The reason I want to leave that in fraction form is I'm going to put that into the formula in a minute, and it'll be a little easier to leave it in that form. Okay. So finally, T is the number of payments times the number of payments I'll make, or 12 times the number of years. So, well, 12 times the number of years is known because the number of years is known. We're told that it was a 15-year loan. And so we get 12 times, we got T equaling 12 times 15, which is 180. Yeah, so we have 180 payments, and we are in business. So now we do what we did before. We're going to rewrite this formula, but we'll just make the substitutions. So we have 300 is for M. That's what our M is. And we're going to say this equals the unknown P times 1 over 600 times 601 over 600. Again, this is 1 plus 1 over 600 to the T, which is 180, all over, again, 601 over 600 to the 180 minus 1. Okay. All right, so now I've got a pretty ugly number sitting right here. So I'm going to go ahead and use a calculator to find that number. And I'm going to have to do my best with my parentheses because there's a lot of parentheses in this one. Okay. So let me clear what I have here. And I'm going to take first 601. I'm going to divide it by 600. I'm going to take the resulting number and I'm going to take it to the 180th power. And I'm going to put that all in parentheses. I'm going to multiply that by 1 over 600. So I'm starting sort of switching these two factors. I just calculated that. I'm going to put this over on the other side. Sorry about that. So I'm going to say times 1 over 600. Great. And now I'm going to divide that by the denominator. The denominator is Well, I'm going to put in, I'm probably doing too many parentheses, but I'm going to go ahead and be conservative and put in as many parentheses as I'm comfortable with. I'm going to get that number. I'm going to take that to the 180th. I'm going to put parentheses around that, and I'm going to subtract 1 and put parentheses around that. And that's my denominator that I just put. That's kind of staring us in the face right now. And I've divided by it, so I'm going to go ahead and calculate this, and I get this lovely number. So let me just keep that number. And if you dislike that number and you dislike the calculation, I'm sorry. Some things are not as pretty. But we have it, and so we will go ahead and write it down. So this is equal to our unknown p and times this number 0.00643 5. I'll leave it there, right? So now, what am I going to do? I'm going to divide both sides by this number that I had. Now, there's a way you can do this without, I mentioned it before, there's a way you can do this on the calculator without doing this estimate. So this is sort of an estimate here, but if you want to get P sort of cleanly without making these approximations, you can essentially say, well, what am I going to look for here? I'm going to look for dividing P by both, or dividing both sides by this number, whatever it is. In other words, I'll take the reciprocal of this number and multiply both sides times the reciprocal. So I'll say, okay, well, this is, I multiply 1 over this number, this ugly number, 0.00643, etc. I can multiply on the right-hand side by the reciprocal of this ugly number, 6, 4, 3, 5, dot, dot, dot. But on this, because I multiplied by this reciprocal, I just get P alone. So you can do this on a calculator. And the way you do this on a calculator, if you have this kind of a number, is you look at this button 1 over x. And if I hit 1 over x, that takes the reciprocal. And then I can multiply. I hope it takes the reciprocal. I'll just go ahead and say equals. That takes the reciprocal, and I can multiply that by 300. And I get the total amount that is that was loaned. So let's take a look. So the total amount is then P equaling 46,619.41 cents. It's a strange number, strange loan, but you know, that's what it is. So your friend borrowed this amount of money, and you can figure that out through knowing this amortization formula. But again, the number that you get at the end is not, I mean, of course, that's the number that we'll be looking at when we grade things or when the computer is checking it. But the thing really to be aware of here is the sort of the technique. And let me summarize one more time. First, with a problem like this, find a formula that works with the problem that you're dealing with. Second, identify all the variables. Find out which variables are given to you in the question and which variable is not given to you. Oftentimes, most of the time, the variable not given to you is the one you're being asked to find. So go ahead and substitute in all of the values for the variables that are given to you, and then solve the simple equation. So you have to do some calculation there, but again, that part is not as important as really being able to follow this sort of procedure. All right, everybody. I hope this helped a little bit with your homeworks. Good luck.